Hi everyone. So I realized I hadn't uploaded the expanding condensing of log properties for 6.5 yet. So I'm going to go ahead and do that now. I know it's a little bit late for the assignment itself, but I've been a little broken on my end. So hopefully this still helps you towards your test, which will be this week. So before I start with this, I do want to touch on the last notes that we did as a class. And it was on 6.2. We did talk about this, about inverses of one another, and we're actually going to come back to this when it comes down to solving logs and natural logs. We're actually going to go back to this section here. But today, what I want to focus on is this Kahoot review, these exponent rules or properties that we talked about. This actually has a lot to do with the properties that we are doing with logs. In case you guys didn't notice the patterns, I do want to make sure I'm explicit about those. So we went over five rules here that apply to both variables and natural bases. And I told you the operation that you would do for each one. I want to focus on three specific ones for this. I want us to focus on the product rule, the quotient rule, as well as the power rule. And I kind of want to write that in terms of our log properties for today. So when we look at product rule, for example, the product means an answer to a multiplication problem. So right here, I'm going to go ahead and say that when we're multiplying, because that's what a product is, that we are going to add. And I'm going to just say these are like my rules again. All right, the other one we talked about was the quotient rule. So the quotient is when we're talking about a division problem. So right here, I am going to say divide. And when we do that, we're talking about subtracting. So we're going to subtract, and I'm just going to abbreviate that because I still want room for one more. And that is the power rule. So when we have a power rule, we're actually talking about those exponents. So 1 base 2 exponents. So instead of writing a power, I'm just going to write exponent so we can remember it a little bit easier. I'm just going to put abbreviated again. So exponent. And our rule told us that we're going to multiply. Like this. Okay. So now we took those main rules and we are going to apply them to our log property so that you can see they're kind of really similar. All right, so for this first rule, the multiplication addition property, we're going to look at a log that has the multiplication. So I'm just going to say log base b of m times n, and we're going to expand that. So we're going to make it longer. Our rule tells us that we're going to add. So the two things that we're multiplying, we're actually going to break those up and combine them with an addition. So I'm going to take my log base b from here, and I'm going to write my m first. Then I am going to add log base b of our second one. So again, multiplication means we're going to add log base b of m times n. I'm going to take the first one, log base b of m, right here, combine it with an addition symbol, and then do the second one, log base b of n. Now let's do division. Let's say I have log base b of m over n. So here we had multiplication, here we have division. We're going to combine these with subtraction. So again, take log base b, and we're always going to do the numerator first. of m minus log base b of n. And then lastly, our exponent one. So let's say we have something like log base b of m to the power of n. For this, we are going to use multiplication. So what we actually do is we're going to take this exponent, and that gets multiplied out in the front. So we're going to say n, and then I'm just going to put my little dot for multiplication. You don't have to, but I just wanted to show you the operation there. Log base b of n. Okay, so now let's look through some examples that you did in your big ideas that will have these, if not some of those combined. One thing I do want to point out though is that these operations go both ways. So when you're given a multiplication, you can expand it to addition. But if we're talking about condensing, and I'm going to underline in orange, you could actually be given something like this that is combined with addition, and you could condense it just by going the other way. So in orange, I underline. In orange means you can go the other way too. So if you're given something with subtraction, again, you could condense it just by going the other way. If you're given something with multiplication, you can condense it, again, by going the other way. So these rules go both ways. Let's look at some examples now. Okay, so let's look through these examples. The first one is pretty simple. So we have log base 3 of 4x. So you're going to look at this part here and you're going to ask yourself what operation is going on here. So is this multiplying, is this dividing, or is this an exponent? For this one here, when you have a number and a variable next to each other, you are multiplying. So you're going to expand by adding 2. So I'm going to take my log base 3, and I'm going to take that very first one, which is 4, and then I'm going to combine it with an addition symbol, and then write again log base 3 of the second term, which is my x. So again, I took this and I split it up. I combined it with an addition because they were being multiplied by each other, and then I just put a log base 3 for each one. So this one would be very similar. We have a log base 8. It's multiplying, so I know I'm going to combine it with an addition symbol. And all I have to do is take my 3x and split it up. So here is 3 and here is x. Since I can't simplify either one of these anymore, I am done at that point. Looking at the next two though, these require a little bit more steps. So the first thing I want to look at is that these two, there's two terms here. And yes, there's an exponent. So I know I'm going to be doing multiple rules. But this part here, the exponent is only with the x. So I can split this up into one term here and one term here for now. These two terms are being multiplied. So I'm going to expand it like I did here. So log 10 multiplied. So I'm going to add log x to the power of 5. Okay. Then I notice that in this one here, I can still expand this because this has a power of 5. So it has an exponent. I can expand it by multiplying, simply by taking that and turning it into a coefficient. So again, I'm going to bring my log 10 plus bring my 5 and get log x. Now this one has an additional step. You should have seen in Mr. Armitage's YouTube video that when you don't have, just like when you have an x, if you don't have a number in front of it, you know it's automatically a 1. Or the exponent, for example, if you don't see a number, you know that it's a 1. When you have a square root and you don't see a root out in the front of it, you know that it's going to be a square. So here, when you have a log and you don't have a number right here, you can assume that that number is 10. So here you have log base 10 of 10. But that is actually just equal to 1. And I'll take it off to the side here and explain why in a second. But this would be your final answer. Whenever you have a log or a natural log that has the same base as it does the term, it will always equal 1. And let's take this one here, for example. And I'll do a little window right here, right? Okay, so let's say log base 10 of 10. We are trying to prove, so I'm going to put a question mark, is it equal to 1? So is that statement true? And that would be true for anything where the base is equal to the term. So if I rewrite this as an exponential, so remember my whale, 10, 1, 10, 10 to the power of 1 is equal to 10. And this would always be true as long as your base and your term are the same number. So for example, this is a base 8. If this was an 8 here, you could assume that that would equal 1, because if you take it off and expand it into, or turn it into an exponential, you could see that that would always be true. So here, I'm just going to make it a little check mark, and that is just the rule. It's another way to kind of simplify things. Okay. So let's look at the next one here. Again, I'm going to take my two terms, and I'm going to expand that first. So I'm going to have the natural log of 3. Remember, multiplication is addition. Natural log of x to the power of 4. We're not quite done yet because we still have a power. We still have an exponent. So 4 natural log of x, and then natural log of 3. And then the last one I'm going to do for expanding is this one here. So in this one we have division. So when we divide, we're actually going to subtract. So I'm going to take, remember the first term is always the numerator. Instead of addition, it's going to be subtraction. Now, once you subtract, you don't have any more fractions because the subtraction is implying the fraction itself. Okay, so here we can expand this one here. So I'm going to take my natural log of x minus, and then I can expand this, right? So 3 and y, they're being multiplied. So I'm going to take my natural log of 3. But since this is a term itself, I'm going to make sure I put that in parentheses, plus my natural log of y. Now, it's important that you remember that this is a term in itself because now you have that negative sign. So you want to make sure that you distribute that in. You get natural log x minus natural log of 3, which you would have gone anyway. But in this part here, you want to make sure that you carry in that minus sign too. And you would have gotten this. So again, for this section, we haven't really done much math. It's just a whole bunch of rules. So let's look at some condensing now. All right, so now instead of going from 1 to an operation with addition, subtraction, multiplication, now we're going to take this long ones and we're going to shrink it into something smaller. It's condensing. So when I see the subtraction sign, I automatically know that it means division, because if I look back at my table, when I have subtraction, it means division. So I'm going to take my log and its base, and I know that the numerator always goes first, so it's going to be 6. Subtraction tells me it's division over 2. So now I can simplify 6 over 2, so that becomes log base 3 over 3. Now, if this was asking you to just rewrite it, you could leave it like this. But if it was asking you to solve it, remember that when the base and the term are equal to each other, this would just equal 1. I think that in your assignment, it was just asking you to match which one was true. So your answer would have been that one. Okay, for the next one, I see that I'm multiplying here. So again, I'm going to write my log base 3. I'm going to bring my 6, and this becomes the exponent like this. So then I get log base 3 of 6 squared, which becomes log 3 of 36. Again, I'm going to bring down log base 3, 2, and since it's being multiplied, it becomes an exponent like this. So then this becomes log base 3 of 2 to the power of 6. I'm going to say, I think it's 64. Pretty sure. And then for the last one, so this one is addition. I know I'm going to be multiplying something. So I'm going to bring my log base 3. And I'm going to be multiplying the 6 and the 2. So in parentheses here, just so I know it's a separate operation, I'm going to do 6 times 2. Well, 6 times 2 gives me 12. Therefore, that becomes my answer. And that is pretty much all you need to know about expanding and condensing, is relating it to the same exponent rules that we've been doing. The same general idea stands. If you multiply, you add. If you divide, you subtract. If you have an exponent, you're multiplying. And know that those go both ways. So whether it's asking you to expand or whether it's asking you to condense, those rules would still apply for each one. I am going to work on a solving video next. That should be uploaded here hopefully soon. And then hopefully, if I get to it, I will record a chapter summary test like I usually, or video like I usually do. But I'm just going to focus on the parts that are actually going to be on your test. So look forward to those, hopefully. And I hope to see you guys soon in one way or another. Let me know if you guys need anything. That's it for now. Be good, be great, be beautiful, and good luck.